There is a battery buried beneath your feet right now. It does not cost $25,000. It does not cost $500. It costs $35. And it has been running since 1839 without ever stopping. Not for a few hours, not for a few weeks, for entire decades. No lithium, no cobalt torn from Congolese soil by children's hands. No factory in China, no monthly bill. Just two metal rods pushed into moist earth. And a law of physics that power companies have prayed you would never learn. In 1839, a Scottish inventor proved that soil itself generates electricity. Not a trickle, not a laboratory curiosity, real, usable voltage pulled from the ground beneath an ordinary garden. He powered a telegraph line for over a year. No fuel, no moving parts, no bill. The British Royal Society documented every experiment in detail. Then those documents quietly disappeared from public libraries. That is not a coincidence. That is a calculation. You could not have known this. Nobody taught you this. It is not your fault. But today, that changes. Welcome to Hidden Fix. This is where we dig up what the energy industry buried deeper than the electrodes themselves. The Royal Institution of Great Britain confirmed it as early as 1841. A single properly built earth battery cell produces approximately 0.7 volts continuously. Licensed electricians charge between $150 and $400 an hour to work on a solar system. What $35 of materials buried in your backyard handles in one afternoon with no specialized tools? By 1910, earth battery patents numbered in the hundreds across Europe and North America. By 1950, almost every single one had been purchased and shelved. Not by universities, not by governments seeking to protect citizens, by the companies selling you electricity right now. They did not bury this technology because it failed. They buried it because it worked too well. A power source that runs on dirt cannot be fitted with a meter, and what cannot be metered cannot generate profit. The global electricity market generates over $400 billion in annual revenue. Every kilowatt flowing through a meter puts money into a utility company account. A copper rod buried 36 inches deep producing free voltage from soil is, to these corporations, an existential threat. Not an innovation, a threat. The year is 1841. The workshop is small, cluttered, and smells of hot metal. The man working inside is named Alexander Bain. He is not wealthy. He has no connections. He never attended a university. He is a clockmaker, with calloused hands and an obsession with electricity. On an ordinary September afternoon, he drives a copper rod into the damp soil behind his Edinburgh workshop, then a zinc rod, a few steps away from the first. He connects the two with a thin wire. The needle on his galvanometer swings hard to the right. Current is flowing. From the earth itself, not from a jar of chemicals, not from a spinning generator, from mud and rain and two pieces of scrap metal pushed into Scottish grass. Bain immediately understands what he is holding. This is not an experiment. This is an engine powered by the planet itself. The principle is devastatingly simple, and that is exactly what made it dangerous. Two different metals buried in moist soil create a galvanic cell. The minerals and moisture in the ground act as the electrolyte. Ions migrate from one electrode to the other through the wet earth. This generates a steady, continuous, low-voltage direct current, with zero fuel input. The deeper you bury the electrodes, the more stable the voltage becomes. The farther apart you space them, the higher the output climbs. Within months, Bain files a patent for what he calls the earth battery. By 1850, earth batteries were powering telegraph lines across the entire American frontier. A man named Daniel Drew in rural Pennsylvania ran a complete telegraph station on copper plates buried in a farm field. No coal, no kerosene, no steam engine, just metal in the ground and a wire running to the telegraph office. The United States Signal Corps documented earth battery stations from Montana to Texas. Some of these buried electrode systems ran continuously for over a decade without any maintenance. Government surveyors in the 1870s reported earth-powered telegraph relays across remote desert terrain. Then came Nathan Stubblefield, a farmer from Murray, Kentucky. In 1892, Stubblefield buried iron and copper coils behind his farmhouse, and he transmitted the human voice through the earth itself, wirelessly, over a distance of several hundred feet. Witnesses signed sworn affidavits confirming they heard clear speech from transmitters buried in the ground. A local newspaper reported that Stubblefield had created a telephone that needed no wire and no battery. In 1902, he gave a public demonstration in Philadelphia. Thousands of spectators watched a man pull electricity and sound from the soil of a public park. Then, here is what happened next. And this is the part most people never hear. The global electricity market generates $400 billion every year. $400 billion every year. From high-voltage transmission lines to the meter on your wall, the flow of money never stops. In the United States alone, households spend an average of $1,500 per year on electricity. 130 million households. Billions collected every month from a resource that physics makes freely available in the soil beneath their feet. A researcher at the University of Michigan measured sustained output from a buried cell array over 7 years. The voltage did not drop. The current remained stable through winter frost and summer drought. The electrodes showed minimal corrosion after 84 months of continuous underground operation. 84 months. 7 years. No maintenance, no replacement, no bill. A study published in the Journal of Applied Electrochemistry confirmed that soil galvanic cells maintain output for decades. Clay-rich soil produces up to 3 times the voltage of dry, sandy ground between identical metal rods. Adding a handful of wood ash or crushed charcoal around each buried electrode boosts output by 60%. 60%. With wood ash. This is not fringe science. This is not a conspiracy theory. This is basic electrochemistry. The same principle inside every commercial battery sold at hardware stores worldwide. The only difference is that the Earth version cannot be shrunk into a product and placed on a shelf. This is not an energy problem. This is a business model. This video is just the first layer of Turned Earth. There are dozens of solutions like this one. Techniques, methods, physical principles that billion-dollar industries have made disappear from public knowledge. Not because they fail, precisely because they work too well. If this kind of content has value for you, subscribe now and hit the bell. Every week we unearth a solution the industry preferred you forget. And share this video with someone you know is still paying $1,500 a year for electricity without ever having seen what $35 of copper and zinc buried in the ground can do. You just saved them a fortune with a single share. Now stay right here, because what comes next is the part power companies really do not want to go viral. The reaction at work is called the galvanic effect. 2 different metals immersed in an electrolyte, here mineral-rich moist soil, spontaneously generate a potential difference. Copper and zinc are the most effective metals for this application. Copper forms the positive terminal of the cell. Zinc forms the negative terminal. Zinc ions slowly dissolve into the soil electrolyte, releasing electrons that flow through the external circuit toward the copper rod. That flow of electrons is your electric current. In 2019, researchers at Wageningen University in the Netherlands confirmed that soil batteries with metal electrodes maintain measurable power density over extended periods under natural field conditions. Laboratory measurements show that a properly spaced copper-zinc cell in moist clay soil produces between 0.6 and 0.8 volts of continuous voltage. 10 cells wired in series along a backyard trench, 7 volts continuous. 20 cells, 14 volts, 14 volts. Enough to charge any 12-volt battery bank every single day, day and night, in rain, under cloud cover, through winter, in deep forest with no sunlight reaching the ground. A 12-volt solar battery with an equivalent panel costs at minimum $200, and it produces nothing at night, and it produces nothing under heavy overcast. The Earth battery costs $35. It does not know night, it does not know clouds, it does not know seasons. Soil conductivity, its capacity to carry ions between electrodes, varies with mineral composition and moisture content. Heavy clay soils are excellent. Soils near underground water sources are excellent. Dry, sandy soils are less effective but still functional with a wood ash amendment. This is not magic. This is not a promise. This is physics documented since 1839. In 1909, the United States Bureau of Standards published a report confirming Earth battery viability with detailed voltage and electrode measurements across 12 states. 12 states. Real data, real figures, real results. That report was quietly reclassified and removed from the public government document catalog by 1920, without explanation. Around the same time, municipal codes began prohibiting the burial of metallic objects in residential soil. These ordinances targeted exactly the configuration required for an earth battery installation: copper and zinc buried at depth, spaced apart, connected by wire to a residential structure. The regulations did not ban metal fence posts. They did not ban copper or zinc pipes buried beneath homes. They banned the precise arrangement that generates free electricity from the ground beneath your property. You cannot patent dirt. You cannot patent rain. You cannot patent the electrochemical reaction between zinc and wet clay. And what cannot be patented cannot be monopolized. And what cannot be monopolized cannot be billed to you every 30 days. Nathan Stubblefield learned this the hard way. Within 2 years of his public demonstration in Philadelphia, his funding had completely dried up. Investors pulled out after meetings with representatives from newly formed telephone utility companies. His patents were purchased by intermediaries linked to early Bell subsidiaries. Stubblefield died alone in 1928, starving and penniless in his own farmhouse. His earth battery devices were confiscated from the property. They never surfaced in any archive. In 2014, a homesteader in rural Arizona built a 50-cell earth battery array on his own land. He powered lighting, a water pump, and a radio station entirely from buried electrodes in desert soil. The county issued a code violation and fined him $8,500 for producing electricity from the dirt he owned. $8,500 for $35 of copper and zinc buried in his own ground. The message was clear to every neighbor watching that legal battle unfold in a small rural courtroom. Free energy from soil is not just forgotten. It is actively punished by regulatory systems protecting utility revenue. Silence is more profitable than prohibition. Here is how you build a working earth battery. Everything you need comes from any hardware store. Step 1. Buy bare 14-gauge copper wire, the type sold for electrical installations, about $8 for 16 feet. Step 2. Get galvanized zinc flashing strips, the roofing sill flashing sold in rolls in the roofing section, about $6 for 6 feet. These are your positive and negative electrodes for 10 cells. Total cost at this point, $14. Step 3. Choose a location with slightly moist soil. Near a slope, a watered garden bed, a vegetable patch. Dry, sandy soil works less effectively. Moist clay soil is ideal. Step 4. Dig 2 holes per cell to a depth of 36 inches. Space the 2 holes of the same cell 48 inches apart from each other. 1 hole for your copper coil. 1 hole for your zinc cylinder. Step 5. Before backfilling, add a handful of wood ash mixed with crushed activated charcoal around each electrode. Wood ash significantly increases soil conductivity. It is not toxic. It does not contaminate the water table, and it costs you nothing if you have a fireplace. This amendment boosts the output of each cell by 60%. 60% more from the ash in your fireplace. Backfill the holes with the original soil. Step 6. Connect the positive terminal of one cell, your copper coil, to the negative terminal of the next, your zinc cylinder. You are building a series circuit, 10 cells in series, 7 volts continuous. 20 cells in series, 14 volts continuous. Total cost for 20 cells, $35. Step 7. Connect the output of your series to a 12-volt battery through a simple blocking diode. The blocking diode costs less than $1. It prevents the battery from draining back into the earth array at night. Your 12-volt battery charges continuously, day and night, in rain, in winter. Important safety note. The moist soil around the electrodes presents no electrical danger. The voltage produced is too low to represent any risk, but always install the blocking diode to protect your battery from reverse discharge. Also be aware of local codes in your area. Some municipalities have regulations on metallic objects buried in residential soil. These are not natural laws. These are ordinances designed to protect an industry's revenue, but it is better to know them. A camper in Minnesota ran complete LED lighting for 3 months on this system. A homesteader in Oregon powered a water pump for over 2 years from buried electrodes. A survival instructor in Appalachia charged radio batteries through an entire winter with a demonstration array. None of these builders spent more than $38 on the complete installation. None asked permission from a utility company. None filed a grid interconnection application. $35. One afternoon. Decades of silent, invisible electrical production from the ground. Now let me be honest with you about one thing. The earth battery will not run your air conditioner. It will not power a full-size refrigerator in a suburban home. The voltage is real, but the current is modest. It is best suited for lighting, device charging, communication, and low-draw appliances. That is a real limitation. and I am telling you clearly. But that is precisely why the suppression makes no logical sense. If it were truly useless, the industry would have ignored it. It would not have spent a century systematically erasing it. It erased it because a person capable of generating even basic electricity from soil stops being a customer forever, and a lost customer is lost revenue, multiplied by every neighbor who watches and learns to do the same thing. Let us go back to Nathan Stubblefield. The year is 1902, Philadelphia, a public park, thousands of spectators. A farmer from Kentucky pulls electricity and sound from the soil of a major American city. The newspapers cover it for weeks. 20 years later, Stubblefield is dead on his farm, alone, starving. His devices confiscated, his name erased from the official history of electricity. But the soil beneath that Philadelphia park has not changed. The soil beneath your backyard has not changed. Copper and zinc have not stopped reacting with moist earth simply because a patent office filed the documents away. The ground beneath every campsite, every garden, every forest on this planet is still generating voltage right now. It has been generating voltage since before humanity existed. We did not lose the Earth battery. We were told to forget it. But forgetting is not the same as erasing. The chemistry survived because physics does not answer to corporate revenue. And now you know what they spent a century making sure you would never learn. A battery that runs on dirt. That costs $35 to build, that lasts for decades, and that cannot be controlled. Share this video with someone who deserves to know what $35 buried in their backyard can do. Every share preserves what the energy industry tried to bury deeper than the electrodes themselves. The next video is even heavier.